Hey everyone, welcome to my Intro to Physics episode number 4. Today is going to be about exploring hollow shapes and how to solve for a mass. Let's jump into reading the question. What is the mass of a material with density, or rho, that is a hollow sphere with an inner radius of r sub 1 and an outer radius of r sub 2? This seems like a short question, but don't be deceived by question lengths. The question refers to a hollow sphere, so let's draw one outer sphere and try to draw an inner sphere somehow. I marked the different radius so you can hopefully see the outer shell versus the inner shell. If we think about what the question is really asking, we have an outer sphere with a mass and an inner sphere with technically no mass. So if we subtract their total sphere masses, big minus small, we should be left with the mass for just the hollow sphere. Relating to what we have, we can take the sphere with bigger radius r sub 2 and subtract the smaller sphere with radius r sub 1. So moving on to our variables, the radius of the inner sphere is given with r sub 1. The radius of the outer sphere is given with r sub 2. The density of the material is the same for both the inner sphere, which is rho, and the outer sphere, which is just rho. If we want to subtract their masses, then we will need to solve for the mass of the inner sphere and mass of the outer sphere. This will give us the mass total for our hollow sphere, which is the mass of the outer sphere minus the mass of our inner sphere. Now to determine how to use our variables of radius and rho to be able to relate and calculate the mass. If we go ahead and write the density formula out, the density formula does have mass in it, and it does have volume. And remember, the volume of a sphere is 4/3 pi times r cubed. This equation happens to fit just right to relate to both our mass and radius. This is quite a common theme here with the density formula. So let's solve for just mass, giving us mass equals rho times volume. Or mass equals rho times 4/3 pi times the radius cubed. This gives us our radius, rho, and mass relationship. Now that we have the relationship, it's time to calculate. Start with rewriting the equation for our mass, which equals rho times 4/3 times pi times the radius cubed. So let's go ahead and label this one as r sub 1 and rewrite this for our other radius, r sub 2. Now that we have the two equations for mass, to find the mass total, we need to subtract the bigger mass minus the smaller mass, which is mass sub 2 minus mass sub 1. And so now we can substitute and plug in rho times 4/3 times pi times r sub 2 cubed for our mass sub 2, and the same for our mass sub 1. So now our mass total equals rho times 4/3 times pi times r sub 2 cubed minus rho times 4/3 times pi times r sub 1 cubed. Our rho, 4/3, and pi are all the same constants, so can be factored out from both terms. So this simplifies our mass total to just be rho times 4/3 times pi, all times our radius r sub 2 cubed minus r sub 1 cubed. For our hollow sphere, we have found the total mass equaling rho, or density, times 4/3 times pi, all times the radius r sub 2 cubed minus r sub 1 cubed. Now that we have solved for this hollow shape, let's actually explore a little more and add another geometry shape to the problem. Part 2. So continuing with the previous question, now what would the mass be with an added smaller sphere inside of the hollow sphere with radius r sub 3? Now we have a hollow sphere and a solid sphere. With the hollow sphere already drawn, we can just add a small solid sphere, or something sphere looking, inside, and mark the new radius r sub 3. Relating to what we have, to calculate we need the biggest sphere, radius r sub 2, minus the smaller sphere, radius r sub 1, to get the hollow sphere, which then we can add just the solid sphere with smaller radius r sub 3. Our equations will be similar, with mass total equaling mass of the outer sphere minus mass of the inner sphere, adding the new smallest solid sphere, mass sub 3. With our equation set, it's time to calculate. Start with rewriting the equation for mass, which equals rho times 4/3 times pi times the radius cubed. Let's mark this one for radius r sub 1. Let's rewrite and mark for radius r sub 2, and rewrite one more time and mark for radius r sub 3. With three equations for mass, we can now solve for total mass of our system. The mass total will equal mass sub 2 minus mass sub 1 plus the final mass sub 3. So now, substituting for all the masses, we should end up with rho times 4/3 times pi times r sub 2 cubed minus rho times 4/3 times pi times r sub 1 cubed, and adding rho times 4/3 times pi times r sub 3 cubed. Again, since all of these are spheres, they all share the same constant rho times 4/3 times pi, which can be factored out of all three terms here. We end up with the mass total equaling rho times 4/3 times pi times all of this in the parentheses, which is r sub 2 cubed minus r sub 1 cubed, adding r sub 3 cubed. This is our final answer now for this extra little bonus. The mass of a hollow sphere with another solid sphere inside is rho times 4/3 times pi, all times our radius, sub 2 cubed minus r sub 1 cubed plus final r sub 3 cubed. This question is mostly figuring out a decent drawing to really see what it is asking. This should be able to apply to all hollow geometry or other shapes within shapes, or shapeception. Say that 10 times fast. With our problem now solved, I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting material, and see you next time.